All right, Matthew. So here's the deal. I'd started the last video and like I was going to sneeze, so I paused it and then I accidentally hit the stop button. So I got halfway through and then it stopped. And at this point, I'm like, there's no way I'm going to redo all that. So I'm not going to redo all the writing, but I'll redo the explaining. Dang it. So anyways, we're going to multiply and factor by GCF during this section. So our question is, how are multiplying and factoring related to each other? We're going to see that pretty quick. So we're going to start with multiplying using the distributive property. So we know the distributive property when we have something times, a polynomial or a binomial in this case, that this number here gets multiplied by both of these. So that's why we got a times b and a times c. So ab plus ac. So here's a problem where we're going to distribute. So I'm going to take 5n and multiply it by 3n to the third. Remember, 5 times 3, we multiply the coefficients, get 15, but then we add the exponents and get 4. 5 times negative 1, we get negative 5, and then we add the exponents, get n to the third. 5 times 8 is 40, and there's only an n there. So we get 15n to the fourth minus 5n to the third plus 40n. Okay, next one. This one has two places to distribute. So I'm going to start over here. 3 times 1, we get 3. And then x to the 1 plus 2, because we add the exponents, we get x to the third. 3 times negative 1 is negative 3. And then x times y is just xy. Over here, negative 6 times 1. So I'm looking at the coefficients. That's negative 6. I've got x to the first and x to the first, so I add those and get x to the second, and then the y. Negative 6 times negative 3 is positive 18, and then we get xy. So you can see up here, I wrote down the degrees because I need to combine my like terms at this point and also put it into descending order. So this end had third degree, second degree, third degree, second degree. So I started by looking at my third degrees because they have to come first. But they're not like terms, so I can't combine them because this one's x to the third and this one's x squared y. So they're not the same. So I have to say which one goes first. Well, I start with the variable. They both have x's, so that's still a tie. Then I look at the exponent. This one has 3, this one has 2. So this one wins because it has more of that first exponent. So I put 3x to the third first, and then I put negative 6x squared y second. My two that are to the second degree, I look at them and I notice they have the same variables to the same powers. This one's xy, this one's xy. So I can combine them. And remember, when we combine like terms, we just take the coefficients. Negative 3, positive 18, that gives us 15, and then xy. All right, that gets us to greatest common factor. So a factor is something that's being multiplied. So what we're looking for is the biggest multiplier that everything has in common. So they all have the multiplier, and it has to be the biggest possible multiplier. So on this one, I want to find the GCF, the greatest common factor, of 9x to the 6th, 15x to the 4th, and 12x to the 2nd. First thing I'm going to do is I'm going to look at the coefficients, 9, 15, and 12. So I break it down up here. 9 is 3 times 3. 15 is 3 times 5, and 12 is 3 times 4. So the biggest multiple or factor that they all have in common is 3. Really what we're looking for is what's the biggest number that will go into 9, 15, and 12 evenly. So the biggest number that goes into 9, 15, and 12 is 3. So part of my GCF is 3. But GCFs are not just the coefficients. We also look at the variables. This one has x's, and so do these. So they all have x's in common. So we're looking for that. If this one didn't have x's, they wouldn't all have x's in common, but they do. Okay, so how many x's do they have in common? A lot of people say, oh, x to the 6th. But this one only has 4 x's. It doesn't have 6 of them. This one has 2 x's. So I can't say x to the 4th because this one doesn't have enough. So x to the 2nd is the most that they all have, right? This one has 6 x's, this one has 4, this one has 2. So they all have at least 2 x's. So 3x to the second would be my GCF. And now to the part where I sneezed and totally ruined my last set of notes. But anyways, here we go. Factoring by GCF is the opposite of the distributive property. So what we're going to do is we're going to take polynomials and then turn them into multiplication problems. We're going to undo the distributive property. So here's how we do it. The first thing we're going to do is look for the GCF. So looking at 81 and 9, what's the biggest number that goes into 81 and 9? Well, it's 9. 3 does go into both of those, but that's not the greatest number. Remember, it has to be the greatest number that will go into them. Now we look at our variables. I saw that I have 2x's here and 1x here. So how many x's do they both at least have? Well, this one has 1 and this one has 2, so they both have at least 1. So I took out an x. For my y's, I've got 5 y's here and 4 y's here. So they all at least have 4 y's. This one's the only one to have 5, so this one doesn't have 5. So you can't say y to the 5th. Basically, you're looking for your smallest exponent for your variables. So y to the 4th. So there's my GCF, and that's where I sneezed last time. So once we find the GCF, our next step is to divide the polynomial by the GCF. And this makes sense when you realize that what we're doing is undoing the distributive property. Now, the distributive property is multiplication. So if I want to undo multiplication, I should be dividing. So I'm going to divide this one by 9x to the xy to the 4th. I'm going to divide this one by 9xy to the 4th. So I'm going to divide both of these because remember, I'm undoing the multiplication that happened earlier. So 81 divided by 9 is 9. X to the second divided by x is x. Y to the 5th divided by y to the 4th is y. Over here, negative 9 divided by 9 is negative 1. X and x cancel each other. My stupid lights went out. This is not a good day. And then y and y to the 4th, they both reduced each other. So I have now divided the polynomial by the GCF. Okay, so step 3, put the quotient in parentheses. Parentheses. All right, so this is the quotient. So that's what the answer you get when you divide. So I'm going to put it in parentheses. All right, last step. Put the GCF outside the parentheses. So the GCF was 9xy to the 4th. And now we have a distributive problem. Basically, we have undone the distributive property. Now, you can always check your work by multiplying this back out. If you multiply here to here and here to here, you should get what you started with up here. And if you look at this, yeah, it's going to work. So this is factoring. We have undone multiplication. So we've turned this into a multiplication problem. All right. 3 more examples. All right, number 5, we're going to factor this one. So remember what we do? We look for the GCF first. All right, GCF. All right, so I've got 6, I've got 18, I've got 27. What's the biggest number that goes into 6, 18, and 27? Let's see, 6 is 3 times 2. 18 is 3 times 6, and that's 2 times 3. So look now, right now it looks like 6 goes into 6 and 18. So you might be thinking, my GCF is 6. But the problem is 6 doesn't go into 27. 27 is 3 times 9 and 3 and 3. So all they have in common is 3. See, 9 goes into these two numbers, but 9 doesn't go into this one. 6 goes into both of these numbers, but 6 doesn't go into this one. So we're looking for the number that they all have in common. And it just so happens that 3 is the number they have in common. So our GCF is 3. Now we're going to look at our variables. This one has an x, x to the 4th. This one has x to the 2nd. This one has x to the 1st. Now, how many x's do they all have? Well, this one has 4, 2, and 1, so they all have at least 1. So x. Now, this one has a y, but these ones don't, so they don't have it in common, so it's not going to be part of our GCF. It looks like that's our biggest GCF. So what do we do next? Step 2, it said divide the polynomial by the GCF. So I'm going to divide this by 3x, this by 3x, and this by 3x. So 6x to the 4th divided by 3x should be 2x to the 3rd. Negative 18, x to the 2nd divided by 3x should be negative 6x. Negative 27 divided by 3, that's negative 9. The x is reduced, and I'm left with y. Third step, put parentheses around the quotient. So there's our parentheses. Last step, put the GCF outside. And now we've got a multiplication problem. So we've undone multiplication by dividing out the GCF. Now looking here, you can see that we have successfully gotten the greatest common factor because none of these have any common factors here. All right, next one. Number 11. No, example 6. It says the coefficient's 11 and negative 5. That's what I meant. So does any number other than 1 go into 11 and negative 5? No. What about the x's? This one has 3 x's. Does this one have any x's? No. This one has y's, and this one doesn't have y's. So do they have y's in common? No. Do they have anything in common? No. They have nothing in common. Okay, that means that the GCF is just 1. And whenever the GCF is 1, whenever the biggest number that can go in there is 1, we call this prime. Prime means that this will not turn into a multiplication problem because it's just this times 1. So this is what we would call prime. So an answer of prime is fine if it doesn't factor. This one doesn't. All right, next problem, example 7. 12 and 25. Nope, 12 is 3 times 4, and 4 is 2 times 2. So 12 is 3 times 2 times 2. 25 is 5 times 5. So this one's 3, 2, and 2 for its factors. This one's 5 and 5. There's nothing in common there. So you might be tempted to say, oh, it's prime, because they don't have anything in common. Well, the coefficients don't have anything in common, but look, they both have x's. So the GCF in this one is going to be x squared, because this one has 4 x's, this one has 2. So the most x's they have in common is 2 of them. And then this is the only one to have y's, so they don't have y's in common. Okay, so that's step 1. We found our GCF. Step 2, divide by the GCF. All right, so let's see. This is going to be 12x to the 2nd. This one will be negative 25y to the 2nd. Okay, third step, put parentheses around your quotient. Fourth step, put your GCF outside. And remember, you can always double check your problems by multiplying and seeing if you get what you started with. All right, that is all we have. Remember, you're supposed to answer the question, how are multiplying and factoring related? So hopefully you see how multiplying, or the distributive property, and factoring, how they're related to each other. That's all I got. Not bad for take 2. Have a good day. Bye-bye.